For me, please. Sorry, turn off the lights, Rachel. Okay, so now we are going to go ahead and start to talk about logistic models and how we actually developed these, and you will see that we're going to use exactly what we just found, partial fractions, in order to discover, okay, well, what is our formula here? So let's go ahead and go down here. This is just going to be one big problem. I love this problem, though. It's even better than the Newton's law of cooling one. So here is our formula for a logistic function, where we have k times the population multiplied by some maximum carrying capacity. As we talked yesterday, if we let the bacteria grow, they would grow bigger than the universe, correct? After a certain amount of time. However, why can't they do that? Because there's a maximum capacity that they have, usually involving space or resources, food like that. That is what our M stands for. So we have dP, the population, the change in population over the change in time, is equal to some constant k times the population times the maximum carrying capacity minus the population, M minus P. Okay? So, as we recall, this looks like, this is going to create a graph that looks like so. Where we have an asymptote here and an asymptote here. We cannot go below 0 and we cannot go above the maximum carrying capacity. Okay? So what is the carrying capacity for these bears? Given this equation, we have dP over dt equals 0.008 p times 100 minus p. If you look here, what is the M value? It is going to be 100 bears. So therefore my answer is 100. What is the bear population when the population is growing the fastest? Well, when is the population going to be growing the fastest? Well, the 0.008 doesn't do anything to change. The P will change, but if you look here, when are we going to have the largest value here?
P is 0.
And here. Well, when P equals 0, what will we get? 0 on the outside.
So P is 1.
Well, that's 99 times 1, which is 99. This is a logic question. You might have heard of it a while ago. If I have if I have one number and then one other number minus that number, the answer is going to be always half of whatever your carrying capacity is. So if you have 100 minus P times P, it's always going to be half. And the way you can check this really quick is everybody go ahead and on your calculators, do 49 times 51. Because let's say the population was 49, then this would be 49 times 51, which equals
249.
And then if you do 48 times 52 now, what's going to happen? Is it going up or down?
Down.
It's going down. So what's 50 times 50?
One more big.
It's more. And if you start going up or down, what's going to happen? You're going to hit that point. And if you look at this logistic function, that makes sense, right? Because we increase, and then where do we hit? About a half point, a halfway mark. And once we hit that halfway mark, what's going to start happening? We're going to start going back and decreasing. So we go up, hit the halfway point, and then go down. So what is the population the fastest? It's going to be half of M, so 50. Now, let's ask ourselves, what is the rate of change of the population when it's growing the fastest? Well, now all we have to do is take this differential equation and input 50. So therefore, I'm going to get dP over dt, or we can input 50 into there, is equal to 0.008 times 50 times 100 minus 50, which is 50, equals,
12.5.
whoa,
Wait.
you should get 20. 20? Now, recall, this is a rate. So what is this saying? When the bears have a population of 50, when the bears have their fastest population, what is their growth? 20 bears per 1 year. So when there's 50 bears, The next year, we will have 20 more bears. But after that, what's going to happen? It's going to decrease because we cannot reach over 100, and obviously you're going to have less food, less resources, not enough space necessarily. There's always fights that go on. Just anything that happens will start to decrease that rate, and even though you're still increasing the number of bears, the increase is smaller. Now, let's go ahead now and consider, well, we have this equation here, dp. I'm going to have to zoom in here. This is going to be fun. We have dp over dt is equal to k times p times m minus p. Now this equation makes sense. However, we obviously want to take this differential equation and rewrite it as a regular equation. So therefore, what are we going to have to do?
Divide by, move the piece to the.
We're going to move everything that we can down to the bottom, move the dt up to the top, and we're going to solve. So I'm going to write this out as dp over dt. So dp over, and what am I going to divide by? I'm going to divide by p and m minus p, which is going to equal k times, k times dt. Then, what am I going to do? I need to go ahead and integrate both sides. The right side is easy. The right side, we're just going to go ahead and equal. The right side will be, this is going to be the integral of dp over p times m minus p is equal to k dt becomes just kt plus c. However, what do we have to do this right here in order to integrate, anti-differentiate this portion? Not chain rule. What did we just learn?
Natural log.
Not natural log.
Partial fractions.
Partial fractions. What this is called again, just so you know, we call this integration by separation.
Are we going to put 1 over p times n minus p times dp to make it an actual, so that you're able to do it?
So I'm going to rewrite this right here as, I don't know if this is what you're saying. We have the integral of a over p plus b over m minus p. Okay? So now I have to find my a and b value, right? Okay? Well, what do I have on top here? I ignore the dp. Caleb, what is on top there?
A 1.
We got a 1. So I know that, remember, a thing you can do, you can just write this as a times this and p times this. If you only have 2, this is very simple. You're going to write this out as a times m minus p plus b times p is equal to 1. So what am I going to input for p here? For the first one, I'm going to say that p is equal to m. Therefore, the a is going to cancel. I get b times m is equal to 1. Therefore, b equals 1 over m. Then over here, I get that, okay, b times p, so p is going to equal 0. Therefore, I get a times m minus 0 equals 1, and a is going to equal, hey, look at that. We get 1 over m for both of those.
Wait, where did you get the 1?
Because what's in the numerator up here? Just dp.
Oh, yeah. Okay.
Therefore, you get 1 there.
Okay.
Now, I'm going to go back, and now that I know that a is 1 over m, b is 1 over m, I have the integral of 1 over m divided by p plus 1 over m of m minus p dp is going to equal Well, actually, before I do this, the 1 over m is kind of messing with me just a little bit. So what do I want to do with that? What can I do with 1 over m? I can just, can I factor it out? Can I just factor out, because is m a variable or is it a number? M is just a number. M is just the carrying capacity. Remember, the carrying capacity is a number we decide on. What are our variables? Our variables are P and T. M is a constant value. So therefore, what can I do with a constant value? I can factor it out. So I'm going to get the integral of 1 over m times 1 over p plus 1 over m minus p times dp. And what can I do if 1 over m is a number? I can take it from the inside and put it on the outside. And I get 1 over m integral of 1 over p plus 1 over m minus p is equal to kt plus c. So therefore, what can I multiply both sides by then? Multiply by m, and I get the integral of 1 over p plus, and don't be like me, everybody. Don't forget your differentials. 1 over p plus 1 over m minus p is equal to m dp is equal to k t m plus, and then do I have to multiply c by m really? No, because c is some constant, we don't know what it is. We can just keep writing it as c. We can do whatever we want to c and just keep calling it c, it doesn't matter until we find it. So now I need to go ahead and integrate this. Anti-differentiate these two. Remember what I just showed you. What is the derivative of p here? The derivative of p is? Just p? Caleb?
Sorry, so why aren't we multiplying m and c?
It's like saying 2 times a random number. We don't know what the number is. It could be anything.
So, okay.
It just doesn't matter. So yeah, when you have c, just keep c as not being multiplied by anything. So remember, take the anti-differentiate, but what's the derivative of p? It's 1, which means I have to multiply the natural log of p by 1. Anti-differentiate 1 over p becomes, we get the natural log of p. And then here, integrate m minus p. What is the, sorry, not integrate, differentiate m minus p. When you take the derivative of m minus p, the m disappears, and what happens to negative p? It becomes negative 1. So we get instead ln of p minus the ln of m minus p is equal to mkt plus c.
Wait, so how did we get the minus 1 then? How did we get the minus 1? Or like the negative ln m minus p?
How do we get this?
Yeah, why is it the negative?
Because what's the derivative of this in here? We get a negative 1. The negative 1 then goes on the outside. So you take the derivative of this inside, as I said over here. What's the derivative of 3x plus 1? 3. So therefore, what do I have to do? Here I have to divide by 3. Same thing here. The derivative of this is negative 1, so therefore I have to divide by negative 1, which makes this whole thing negative. Okay? So now, okay, this is where some funky stuff happens. This stuff, because of the way the equation is, if you remember, the logistic equation has a bunch of negatives, right? So therefore, what has to happen over here? We have to make these negatives somehow. I'm going to multiply everything by negative 1. This is not something you're going to have to do very often. Don't worry about it. Instead, we get negative. Instead here, these are basically going to switch out. We get the natural log of m minus p minus the natural log of p. Oops, sorry. Minus the natural log of p is equal to negative mkt minus c. And then, if I subtract 2 natural logs, that means I'm doing what with their insides? I am dividing them. So I'm going to get here now m the natural log of m minus p divided by p equals negative mkt minus c. And now that I have this all combined into one, what can I do? Give it a base of e. We cancel that out. We're going to get m minus p divided by p is equal to e to the negative mkt minus c. Again, we're subtracting here, so we could put it on the bottom. I'm just going to think about it as adding a negative. So you can write this now as m minus p over p is equal to e to the negative mkt times e to the negative c.
So minus c. So I could just do minus c.
Yeah, you just have a negative c up there.
But she's saying it's your negative c. Can we just
Yep, and now we can change this e to the negative c. We're going to change that to an a. I have to keep going right now, Caleb, because we only have a little bit of time left. What? What should this?
Yeah, wait, what? This, we didn't.
We multiply by -1 the whole thing, so
Yeah,
we made
but
that
I
negative.
thought the C always.
And it doesn't. It still doesn't matter. So I put a negative here. It doesn't matter if it's negative or positive.
Okay.
Okay. So because I'm going to change this now, because what does e to the c become? We can just assign it anything c. We're going to call it this time a. So I'm going to call a equals e to the negative c. Or since Caleb's making such a big deal about it, m times e to the negative c. There's the m. Do you see the m there? There's the m you were talking about before.
We don't want
And it doesn't matter, because what are we replacing this whole thing with, Caleb?
Hey.
There you go. So it's all a now. So we get m minus p over p is equal to a times e to the negative mkt. Then I'm going to go ahead and separate these two right here into two fractions. I get m over p minus p over p. And what does p over p become? Becomes just -1 equals a times e to the negative mkt. We can add 1 to both sides, and therefore we are going to get m over p is equal to a e to the negative mkt plus 1. Almost, because now all we need to do is switch this around, right? Because I don't want to solve for p, correct? I want to solve for p in this case, because we have dp over dt. P is going to be my output variable. So what do I need to do with these two things? I just need to take this and I need to take this and switch it with that. And we get, as you say, m over a times e to the negative mkt plus 1 is equal to p, and this is our logistic function.
But wait, we can go further.
But wait, we can do even more. No. That is all. So I'm going to leave this up for just 2 seconds real fast.
Dude, that is so much math.
But basically, will you have to do all of this? No.
What? Oh.
If you could understand about 80% of this, you should be good.
Okay,
Okay.
but if you can understand it, we just can never, do it.
Repeat it. So you should be able to do this part here pretty easily. Find the partial fractions, right?
Sure, yeah.
And then you should be able to, at that point, maybe not this because these won't be there. Imagine this is just a number and a number. But you could then get from here all the way to here, correct?
Correct.
By integrating it? Like getting from here to here, if these were different numbers?
Yeah, we just memorize the equation.
This one?
Yeah.
The problem is that I'm going to give you the information like this. So you could try, but you're not going to get all the questions that you want answered there. Okay. As you're looking at this, let me know if you have any questions on this logistic formula before I move it around. Yep.
How did you get ln p minus ln
Which part is it here? Like in which column, which row?
3?
Row 3 here.
Yeah,
How did I get what?
ln there.
Here? How did I get this here?
Minus ln.
How did I get this minus here?
Yeah.
So again, I will write it out really quick. Let's integrate this here. We're going to anti-differentiate 1 over, what's the integral of 1 over m minus p
Is
dp?
it not just the ln of n minus p?
It is, however, notice this here. Is this in the form of what? Remember, we have to replace this with. Whenever we have this, we have to use the chain rule. However, we can skip the chain rule because all the chain rule does is, if we do u here, dp, what is the derivative of m minus p with respect to p? The m is just going to cancel. We'll get du equals -1 dp. Do you see where the -1 comes from, Cody? Alice is going to answer your question.
Yes.
You see where the -1 comes from?
P is a variable.
Yeah, p is the variable because we're differentiating this according to what? dp the whole time. So then, if dp is -1, then I'm going to dp equals du over -1, which means when I replace this, I'll get the integral of 1 over u du divided by -1. What happens there? This whole thing is going to become a -1 over u du. And what's the integral of -1 over u du? The negative just stays on the outside. We get the negative natural log of u. So the idea here is take the derivative of this inner portion here, the m minus p, and then multiply that by the natural log on the outside, which is exactly what we did when Emma asked the question. We had the 3 on the outside, but then what do we have to multiply that by? 1/3. Because what was the derivative of the inside of that natural log earlier? It was 3x plus 1, which became 3, which then became du divided by 3. So therefore that 3 goes right there. Okay? Catherine.
In row 4, when it's the m minus p over p equals e to m, the next one.
Mm-hmm.
Yeah. Why is it still multiplying if you're subtracting exponents?
Because we're adding a negative. So instead of saying I'm subtracting by c, I could have written this as e to the negative mkt divided by e to the power of c, right? How can I rewrite e to the power of c? In the bottom?
C.
E to the c, e to the negative c. Just move it to the top like that.
So is it because they're both negative?
It's why it's because so
Is it because they're both negative that they're still going to...
no. So you're saying it should look like this, correct?
Well, no, I'm saying that, like, I'm confused on why you went from the one to the next one when you separated them. Why-
This is e to the negative mkt plus parentheses negative c. So do you see what I'm adding there? I'm adding negative c. You're not always going to have to do it this way because, again, you're going to have numbers when you do this. This is a very big abstract problem, but in the homeworks that you're going to do, they're not going to be as abstract. Okay? Tomorrow's going to be a big work day for us, so we're going to be able to work through. Oh, sorry. Yeah, tomorrow? Tomorrow.
Is tomorrow Friday?
Tomorrow's Friday. And tomorrow we have the last unit, the last lesson of this unit.
Whoa.
Yeah, this is a fast unit. So we're going to do 7.5. We're going to review Monday, quiz Tuesday, review Thursday, quiz Friday, test Thursday, and then Friday we'll do some kind of party or whatever we want to do.
Yeah.
Yeah.
Is this the last unit of the quarter? How is that?
This is the last unit of the quarter, yes. We got, I think, is this our third unit or our second
This is our
unit?
second unit, so what are we gonna have another unit?
We have one more unit, and then after that it's just review for AP. All right, bye, Abby. Say bye, Abby.
Bye.
Oh, you're
Oh, yeah, say bye to Isaac, everyone.
Bye.
Bye, Isaac. Everyone in here misses you. Some people are still mad, just saying.